Okay, so this is Chapter 3 review. We're going to go over the important concepts in Chapter 3. And we're not going to do a whole lot of questions, but I'm just going to go over and explain some things because we've been through the lessons already. So Chapter 3 is all about statistics. Measures of central tendency are mean, median, and mode. So in 3.1, we talked about mean, median, and mode. Now, you'll remember that the mean is the same as average. Okay? Mean is average. Same thing. Median. What is median? Anyone want to chime in and tell me what the median is? It's the what?
The middle number.
Middle number. That's right. So it's the middle number when the data points are ordered either from smallest to greatest or from greatest to smallest, right? They have to be written in order, and then you count the middle one. So what happens if I have something like this? 2, 3, 5, and 10. What happens if I have 4 values and I'm trying to find the median? What do I do? Is the median 3? 5? Nope. The median then is the average of the middle 2. So if you have an even number of numbers and you're trying to find the median, then you take the average of the middle 2. So the median here is 3 plus 5 divided by 2, which is 8 divided by 2, or 4. And that makes sense that 4 is exactly in between 3 and 5. Okay? So the median is the middle number. If you have an odd number of data values, then you simply take the middle number. So in this case, if I were to do this, right? Well, there's 5 numbers there, so then this is the median. That's the median. Okay? Everyone understand that? Any questions about that, or you guys get that? Okay. So maybe I should back up here. The mode, how about we find the mode here for these numbers that I've stated here. So, sorry, I was going to back up. Mean, I meant mean. So the mean here is the average. And if you're trying to remember how to find the average, what you do is you add up all of the numbers and then divide by the number of numbers. So the mean here is 2 plus 3 plus 5 plus 10 plus 15 divided by however many numbers you have, which is 5. So 2 and 3 is 5, and 5 is 10, 20, 35. 35 divided by 5. That average is exactly 7 then, right? That mean value is 7. So 7 is the number that's that's one of the ways of measuring central tendency. So the average or the mean, the middle number, and the mode are all ways that you can get a general sort of idea about this data. Sort of what's near the middle. What is this data saying? If you had to pick one value, what is this data telling you about? And then the mode is pretty easy, I guess, too, right? The mode is the number that what? Anybody?
That would be the most common number.
Okay, the most common number, sure. Or the number that appears most often in the list, right? So if you have no numbers that appear more than once, then you have no mode. If you have one number that appears the most, then that number is the mode. If you have, let's say, 2 or 3 numbers that each appear the same number of times, then you can have 2 or 3 modes, if that's the case, right? So in this list of numbers right here, there's no mode, right? If I had something like this, if I had another 5 in there, then 5 would be the mode because it appears most often. Now, even though that may or may not be close to the mean or to the median, it still does give us an indication, because it's the most common number, it still is a good indication of sort of what the numbers are telling us. So for example, if I have, let's say we have a test, okay? And we have a whole bunch of, a range of numbers, but we have, 95 showed up more times than any other number. It would be reasonable to say that 95, does provide some kind of indication that that commonality, that number appearing the most times, is an indication that at least a big portion of the class has a really understanding or is near 95, even if the average is 75. Even if the middle number is 82. 95 is still in the consideration because it's the mode. Okay? So, mean, median, and mode. Those are the measures of central tendency. Just interrupt me if you have any questions here now, or put up your hand. Or Have any questions about any of these three? Okay, let's move on then. I've flipped another page here. This is just an explanation, a further explanation of the mean. And when we have kind of a regular average, we call it the arithmetic mean. So in case you see this on your test or in any assignments coming up, arithmetic mean, and you're like, whoa, wait, we talked about the mean, but not the arithmetic mean. The arithmetic mean, arithmetic just means adding, okay, or sum, arithmetic, like sum. So you're just simply adding up all the numbers. So if I want the arithmetic mean, that means I just add up all the numbers. Even if something appears more than once, I add it as many times as it shows up. So let me just show you here. In this list of numbers stated above, 7247013261, we add all of the numbers up even if they appear more than once. So notice how I have 2 7s that I'm adding, and I'm adding the 2 1s as well, and so on. The 2 2s, you see that? So you just add them up. It doesn't matter how many times they show up. Arithmetic mean. Divide by the number of numbers, including all the repeated ones. Okay? Okay. Any questions about that? Okay, some further clarification of the mode here. I just clipped this out of your workbook as well. And the median and the mode, I don't need to go over this, but you can read this if you want. Pause the video or look back in your book and study this a little bit. Median, middle number, mode, the value, or the number that appears most often in a list. The other thing we should talk about is a stem and leaf plot. I think that's come up in your, a few times here, a stem and leaf plot. So why is that helpful? Well, instead of writing each of the numbers down, the whole number, you can actually take a little bit of a shortcut. The other thing that you can notice right away is that you can order the numbers quite a bit easier. And I gave you an assignment, this measures of central tendency assignment. And if you remember here, I gave you a whole list of numbers right here. Whoops, where is it? On this side. Whole list of numbers. And for many of you that started that assignment yesterday, you said that it took you a whole hour just to order the numbers. One of the ways that you could save yourself some time is doing this stem and leaf plot. And I don't know how many of you actually did that. I didn't give you that hint, but this is one way that you can save some time in ordering your numbers. Because if you notice that, let's say the numbers here in A, right? I have some numbers that are in the 20s. I'm just going to highlight them right now. The 20s. Then, you know what? The stem would be the 2 in the 10 spot. So this is 20, and then the leaf would be 5. So this represents 25. Okay, that's this number right here. Then you have 23. That's this one right here, and so on. 28, which I missed. Here's 28. 29 and 22. So you just put the second numbers there in the leaf kind of row. Then from there, it's really easy to order them. You know that you have the smaller numbers on top as you move up, 2, 3, 4, and so on. And then it's really easy to order the leaves there, right? 2, 3, 5, 8, 9. Then you have an idea here. Now you have all your numbers ordered, and it saves you some time. So stem and leaf plot is a good way to order a whole bunch of numbers a little bit quicker. Okay? All right. Now this next page here, and yeah, I did just kind of show how we work this out. Finding the median. If there is no middle number, we take the average, as we mentioned before, of the two middle numbers. Okay. Any questions about stem and leaf plots or mean, median, mode? Okay. Let's keep going. We're a little over half done our review here now already, so this is good. You get some time to work on your assignment and study a little bit later. Okay, so all right, this one. Let's keep going with this. Oh, that's nothing there. Okay, the next big thing we need to talk about is weighted and trimmed means. Okay, so in your workbook, if you're following along, this is page 122. Where are we? Where did that go? I'm sorry here. 118. Oh. Okay. Okay. Trying to zoom in. There we go. All right. So weighted and trimmed means and outliers. So three things. Weighted means, trimmed means, and outliers. The first thing that's talked about here in 3.2, page 122, is the trimmed mean. Okay? Now, you might find the trimmed mean, not the simple arithmetic mean, if, and this is when you would consider this, if you have something called an outlier, or if you have several outliers. So what's an outlier? We better talk about that right now. An outlier, if you recall, and let's take a look at this example here with this group of numbers. An outlier would be one or more numbers that are definitely outside of where most of the numbers seem to be. So it's like an aberration or like a freak number, okay? A freak number, okay? So you want to get rid of the freaks numbers, okay? So for example, 3, 9, 5, 8, 4, 6, and 20. Well, if you think about this, 20 is obviously one that is drastically different than all the rest of the numbers. So that we call an outlier. And there might be multiple reasons for that, but when we're talking about the group as a whole and what is sort of the average, or what is the mean, what is the central message of this data, if there's a data point that was taken, and who knows, maybe there was an error in taking that data point, maybe that was just a one-off and that is not indicative of the situation at all. So what you can do is you can eliminate an outlier. Okay, so that's what an outlier is a number or numbers that are vastly different than the rest of the group. When you take a trimmed mean, though, there's a couple things you need to remember, okay? A trimmed mean may be more representative when we have outliers. A trimmed mean is found by omitting an equal number of values from the upper and lower ends of the data set. That's very important. So I can't just get rid of the 20 and say, you know what, that's just a freak aberration here, I'm just going to get rid of it. You can't just do that. What you have to do is you have to trim the large outlier and you have to trim the smallest one, even if that smallest one is not an outlier. So I'm going to get rid of 20 because that's an outlier, but I also have to get rid of 3 here. Okay? So the arithmetic mean considers all numbers. The outliers are the ones that are drastically different from the rest of the set. And the trimmed mean is just the average or the mean of the remaining numbers after it's trimmed, okay? Does that make sense? So in your assignment, I also asked you to find a trimmed mean for all of these data values. I asked you to choose how many numbers you were going to trim and why. So I kind of wanted to see if you know what an outlier was, and I wanted to see if you know how to calculate a trimmed mean. So arithmetic mean does consider the 3 and the 20. There's all the numbers divided by 7. And I don't know if I have the rest of this, but the trimmed, what page is this? I'll have to go to the workbook. I don't know if I trimmed this or if I got this. 122. No, 125. So let's go back to the workbook here. Nope. Trimmed mean. So the arithmetic mean considers all of them. And here, the trimmed mean, what we would do is they took off the 20 and took off the 3, and look at what's left. Just those numbers. And then they divided it by the number of numbers they added, and that was just 5. So we have a trimmed mean, which sort of eliminates the skewing of the message by the outliers. Okay? Questions about that? I'm actually going to copy that page, put that in my review for next time. See if we can get that done there. Okay, page 125, and I'm going to put that above there. All right. Questions? Yes, no? Outliers, trimmed mean. Okay, what about the weighted mean? Yeah, if you have a question over there, can you just hold on? Are you all right? Okay, I'll get to your class in a second. I'm working with the 12s right now. Okay, so the weighted mean, all right. So this happens a lot in school, okay? So if you have categories of your class, for example, if you have assignments and homework, or assignments and labs and tests or something like that, then sometimes those categories are worth different amounts. So if you write a test, that category of evaluations might be worth more than, homework checks, right? You understand that, right? Homework might be worth 10%. Exams might be worth 50%. That's called a different weighting. Now, when things are weighted differently, we have to take that into consideration in finding an overall grade, for example. So let's say you did really awesome on homework. You got your homework done, and you got 10 out of 10 on every homework assignment you ever did, the whole class. And you got 100%, or you got full marks on the homework section. But when it came time to tests, for whatever reason, you didn't do as well in the tests, and you got, let's say, in the 80s. Let's say you got 85. So here, if considering those two categories only, homework, you're at 100%. tests, you're at 85. Because the test section is worth way more than the homework section, that 85 is going to be worth a lot more than that 100. Okay? So your mark is going to be, if you just considered those two categories, your mark would be much closer to 85 than it would be to 100. Okay? They're not treated equally. It's not like 85 plus 100 divided by 2. No, that's if both of them are weighted equally, 50% each. Instead, we have to consider the weight. So that's the background here. And we've done a little bit of some questions there, and I know some of you have asked me about that even. So I think I would like to do, just this little bit of question here. Example 2A. We might have gone over this in one of the previous lessons, but being that this is the review, you maybe haven't watched the lessons for a while. So let's just take a look at 2A, and I'll test as soon as we find out what her final grade be. Just wait a minute. Maybe this isn't the one I want to do. Okay, that's not the one that I had planned, that I was thinking it was. Let me just get back to, where's 3.3? So let's go back to that. Oh, that's not it either. What page was that? Okay. Well, I tell you what, I might just make up an example here for you just to kind of go over that point. Okay, let's just do that. All right. So, this example 2 is fine, but this is not the basic example that I wanted to give you. So let's say, and let's use that example. Okay, so there are categories, okay? Categories in your math class. There is homework, and that's 10%. There are assignments, like hand-in assignments, and those are worth 30%, okay? And there are tests, and those are worth 50%, okay? And I need to have another category, don't I? Because to have the whole mark, to have your mark, this needs to add up to 100%. So what do we got? 50 and 30 and 10, that is 90. So let's say quizzes, sure, let's do quizzes for 10, right? Quizzes are 10%. All right, so if you had 100% on your homework, your assignments averaged out to be about 80%, let's say. Your tests were 82%, and your quizzes did pretty good, 88%. Right? Actually, let's just say your quizzes were terrible because you didn't study until the test. Oh boy, that's bad. But let's say your quizzes were terrible. So you look at these numbers and you say, well, I could kind of find an average there, it's going to be, with 100 and a couple 80s, boy, it's going to be like close to, maybe 88% or 90%. But then you look over here and you say, you know what, this 100% is not worth very much at all. This 82 is worth the most, and so on. So what you do is you do this. You do 100 times the decimal form of the weighting. And you do this 80% times the decimal form of the weighting. And then, so I'll just kind of keep doing this here. The decimal form of the weighting. And so what happens here is you get these numbers. So 100, so that's 10, right? This is 24. You have to help me out here. 41. And it's 5.8. Can double check some of my numbers there. That's right. Yep. I think it's pretty good. So then what you do here now to get your final mark is you simply add up all of these points that you get from each category. Okay? So you've got your mark times the category percent as a decimal. You add up all those grades. So what is this? 24, 34, it's going to be 70. Oh my goodness. Something's wrong here, guys. 82 times 0.5. Help me out here. 80 times 0.3. 24. 10. 34. Oh, that's 5.8. My bad. I missed that decimal point. So we've got 34, 75, and then 5.8. So that's 80.8. Right? So I thought that was 58. I'm like, what? That's going to be over 100%. So here we go. See how we thought that maybe, oh, look at this, 100, 80, 82. I'm going to have a mark that's right in here somewhere, you know, like 85, 88. Nope. Nope. Because of the weighting, it's not a simple mean, it's a weighted mean. So this is how your mark would be calculated. And that's exactly what we do here at school. If the categories are weighted, then this is how you calculate your mark. Any questions there on the weighted mean? Okay, so that's the main example I wanted to do there. Okay, finally, let's round off our lesson here. I think, unless there's something else you guys have questions about, but percentile ranking is going to be the last thing that we need to cover here. Okay, percentile ranking. Now, if we have a group of numbers, and again, this assignment that I gave you yesterday talks about percentile ranking too. If you have a group of numbers, and let's say we're talking about exams, because we're in school, and we just had an example. So let's say we have a whole class worth of exams, and your exam, let's say your exam was an 85, okay? And considering all of the rest of the exams, there were a few people that got a higher mark than you, and a bunch of people in the class that got a lower mark than you. You could figure out where you stand in the class by calculating your percentile ranking. And that means, for example, if you were in the 90th percentile, or if your percentile rank was 90, what that means is roughly, almost exactly 90%, or roughly 90% of the class had a mark less than yours. Consequently, about 10% had a mark above yours. So we've done the full lesson here, so I won't go through the full lesson, but that's sort of how it works. If you have a number that's near the top of the class, you would have a percentile ranking that's near 100, okay? If you had a mark that was one of the lowest in the class, you would have a percentile ranking that would be pretty low. It doesn't have anything to do with your actual grade or your actual value, let's say height, okay? I'm not a very tall man, okay? So if we have a whole bunch of people lined up, right? And this is the way it always was when I was growing up. I'm about 5'8", so I'm not very tall. But as I'm growing up, right, if we lined up from shortest to tallest, I would always be kind of 3 or 4 in out of 25 or 30, right? So so as far as height goes, my value was nearer to the bottom, so I would have been in the 20th percentile or something, let's say. That means about 80% of the class would have been tall, and that's maybe not 100% true all the time, but do you know what I mean? So it doesn't, grades or height or weight or whatever. And I think I used the example of when I took my one of my children in, and my son for the first time, and they said, yeah, he's in the 85th percentile for weight. I'm like, okay, what does that mean again? Okay. I think I knew at that time because I was a teacher then, but that's the language that they use, and so you need to know how to do that. Now, how do we find that out exactly? Again, went over this in the lesson, so watch the full lesson if you have no idea what I'm talking about. But the percentile rank here, PR, equals B divided by N. And as you recall, the B refers to the number of values or data points that are beneath your value or the value in question. So again, here's all of the guys in Mr. Maxwell's class, okay, and their heights, okay, ish, okay, they're all getting bigger and bigger. So here's me right here, okay? So if I was counting my percentile, I would count the 1, 2, 3 guys that I'm taller than, and that would go here, 3, the number of values beneath. N is the total. How many are there in total? 1, 2, 3, and including me, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are all the guys in the class. 12 is the total. And when you do 3 divided by 12 times 100, you should get 25%, or 25 as the percentile rank. And that means that if this was me lined up with all of my classmates growing up in elementary school, then I would have been about the 25th percentile. Okay? Does that make sense? All right? Okay. Questions? I'm going to erase some of this here. Questions? No? No one has questions? Oh my. All right. Then let me see. Let me just take a quick look. All right, I do want to talk about this specific example. I had a question about this. the repeated, like weighted means repeated items. You don't have to worry about if things are repeated. You can basically just treat it like an arithmetic mean, okay? I wouldn't get too confused about that because look at method 1, you can just calculate the arithmetic mean. So in this example, someone's a server at a restaurant, Glenna, earns 2 tips of $6, 3 tips of 8, 3 tips of 10, and 6 tips of 12. So you can just take each of those, so 6 plus 6, because there's 2 6s, plus 8 plus 8 plus 8, because there's 3 8s, and so on. So you can just add them all up like this. There is a shortcut that kind of looks like a weighted mean process, and that's what this one is. And so I'll just magnify this a little bit. So the other way, the method 2, is to gather the groups of tips, and it's really ends up to be the same thing. So 2 6s plus 3 8s plus 3 10s plus 6 12s divided by, well, you have 2 there and 3 here and 3 there and 6 there. So really it comes out to the, should be the same thing, right? 9.86, sum of the tips, oh yeah, sorry. 9.86, okay, $9.86 as an average. So I wouldn't worry about that one. The weighted means repeated items, you think that's not a separate thing. Just take your regular old average, okay? Regular old mean, okay? All right, so that's a review of chapter 3. That's the whole chapter there. And yeah, you guys can finish your assignment that I gave you yesterday and study, put all this stuff on a cue sheet, you know, a sheet that has everything, and you can just read that over 100 times, you know, tonight, and be ready for it tomorrow. Okay? If you have any questions, I'll be happy to help you there.
Mr. MathWell.
Like the video. MrMathWell.com. Go there now.